Hi guys, welcome back to my YouTube channel, and in today's video I'm going to be teaching you how to find the local maximum and minimum values from a given function. I like to break it down into 4 separate steps. So when you first get a function, what you will do first is take the first derivative and find the critical numbers. I'm assuming you guys already know how to find the critical numbers, but to quickly summarize, what you'll do is take the first derivative, make it equal to 0, and then isolate for the x value. And that x value is going to be your critical number. Okay, and when you get that critical number, you're going to put it on a number line and check the intervals to see where it's positive and negative. Okay? I'm not going to explain too much right now because I'll just show you in my upcoming clips. Okay, yeah, you'll find the positive and negative intervals, and then you'll find whether it's a minimum or maximum. I also have a trick for that because it's not easy to catch. So in the next clip, I'll also be showing you that. And then when you find if it's a maximum or a minimum, you'll then plug that x value into the original equation to find the point. Okay? I know it might be confusing right now, but I will show you in steps right now. Okay, guys, so this is the trick. When you put your critical number on the number line, and on the left side it's positive and negative, that means that the slope is increasing and then it suddenly decreases. So that tells us that at point C, there is a local maximum. Okay? And it's the same thing for when the signs are flipped. So if the left side has a negative and the right side has a positive, that means on the left side, the slope will be negative and then it'll suddenly go up to positive. That makes this a local minimum. So yeah, those are the 2 ways of finding if it's a local minimum or maximum. And keep in mind that if this is just positive and positive and negative, that will indicate that that point is not important. Like it's just another point in your graph. It won't be maximum or minimum. So let's get started on a question. Okay guys, so this is our first example, and here we have to find the local max or minimum of f of x equals x cubed minus 3x plus 1. So as I explained to you the 4 steps, first we're going to take the derivative of this, and we're going to find the critical point. So all you have to do is use power rule. I've shown that in my previous videos, so I'll go ahead and do the first part. Okay guys, so here all I did is find the critical points, so I'll explain from the start. We took the first derivative using power rule. Okay, we just brought the power down using power rule, and then I made the equation equal to 0 so that we can find our critical points. The next is just basic simple algebra. You isolate for just x, and I want to mention, keep in mind when you square root a number, you're going to take the positive and negative version of that to put on the number line. So the next step is to put -1 and +1 onto the number line and check the intervals. Okay guys, so here I put the critical points on the number line, -1 and +1. Okay, I put that on the number line, and as I said, you need to check the intervals. That means you can take test points in between each interval and plug it into the derivative equation that we found. Okay, you'll plug it into the derivative equation, not the original equation. So for this interval, I took -2 as my test point, and I plugged it into f prime, which is the derivative, and I got +9. That makes this interval positive. Okay, I did the same here, and I took my test point as 0. I plugged it into the derivative equation, and I got -3. That means my middle interval is going to be negative. I did the same for this one, and I took +2, plugged it into the derivative equation, and I got +9. That makes this interval positive. So now that you have your signs for each interval, you can tell where you're going to have a minimum and a maximum. Using the trick I told you before, when the slope goes up and then it goes down, you can visualize it. It goes up and then goes down. That means it's going to have a max point. Okay? So the x value for our maximum is going to be -1. And then we can check the same here. The slope goes down and then the slope goes up. That means we're going to have a local minimum. So our local minimum x value is going to be 1. Okay, and before I move on to finding the y values for the points, I want to mention that any point, any test point that you take. You can take -2, -3, -4. Any point that you'll take is all going to result into the same sign. So you don't need to worry about taking the exact numbers as me. Sorry guys, my brother came into the room. So what I was saying is, yeah, you can take any value in between each interval and it's all going to result into the same sign. So you guys don't need to copy the work I'm doing. Okay, and yeah, the last part is using the x values to find the y values for each point because it says to, oh, sorry. Okay, never mind. Okay, so before finding the points, I wanted to show you one more thing. The same thing that I was explaining about visualizing, it's positive and then negative. That makes this point a maximum. It goes negative, then positive. That makes this point a minimum. So you have your x value for the maximum and your x value for the minimum. So what you want to do next is plug this x value into the original equation and find your points for the local maximum and minimum. Okay, guys. So all I did is just plug in the uh, max and minimum values that we got from the number line. I plugged in the local maximum value into f of x, and I got that the y value is 3. That makes our local max point -1 and 3. Okay? And then I did the same for the local minimum. I plugged in the 1 into x, and I found that our y value is -1. That makes our local minimum point 1 and -1. So there we have the question solved, but I do want to show you one more thing on how to visualize it. So one second. So here I drew a rough sketch of what the graph is supposed to look like. This is our local maximum and this is our local minimum. And it makes sense because here the slope is increasing, then decreasing into our local minimum and then up again. And these are just the points that I've plotted from the point itself. So yeah, that's all for this question. Okay, guys, so that's it for today's video. Thank you so much for watching. I've been like really happy with the reach that my videos are getting lately. So yeah, I just wanted to thank you. Also, I'm sorry for the camera quality. I usually film on my laptop. That's why it's not very clear. But yeah, that's it. See you guys next time. Bye.